So the last thing that we want to do is we want to talk about acids and bases, and we want to talk about salts too. Salts are not listed right on this chart, but when most metals and nonmetals come together in an ionic bond, they're going to form a salt. So we've used sodium chloride as a good example of table salt. It's the most common one that we utilize and that we eat. And so it's the one that you're most familiar with. But most metals, when they come into contact with a nonmetal, are going to form a salt. You can have potassium chloride, you can have magnesium chloride, you can have magnesium sulfate, you can have calcium sulfate. You can have all of these different metals coming together with different anions, and these are all called salts. So that's a fundamental unit. Typically, if you see a metal with a nonmetal in an ionic bond, it's going to form a salt. If it doesn't form a salt, it's forming an acid or a base. And these are two very useful nomenclatures. An acid then is a substance that provides proton ions or H pluses in water. So for example, HCl releases the H plus and the Cl minus when you dissolve this in water. So the ions are going to be free floating. If the cation is a proton or the H plus ion, this indicates that you have an acid present. So you can recognize acids when the H is in the cation position. The base occurs in a substance that provides the OH ions. So this is called hydroxide. This is a hydroxide ion. It's one of the polyatomic ions. So if we go back to our polyatomic chart, here's the OH minus is the hydroxide ion. And so this moves together. So when the O and the H are acting as the anion, this is going to indicate that you have a base present. A general definition for a base is a substance that provides OH ions or anions in water. So you'll notice that these ions, the OH anion and the H plus ion, cation, are both components of water. If you put these two together, you would get H2O, right? You've got two H's and one O. So these are essentially the building blocks of the water molecule. When they're present in water and there's not enough of the counterpart to balance it to make a full water molecule, this is when you get an acidic solution if you have more protons present, or you get a basic solution when you have more hydroxide ions present. And these charged molecules are very reactive and they have very caustic behavior. Acids are very caustic substances, right? So we've got stomach acid is HCl, and it has a pH that's really, really low, and we'll talk about what the pH means here in a minute. But it has a pH of about 2, whereas a neutral pH is around 7. And so if the contents of our stomach acid were actually placed on the floor, it is caustic enough that it would eat a hole in the floor. So that's how strong the stomach acid is. And that's due to these free charges that are floating around, the H plus charge and the OH minus charge. So you can recognize an acid and a base, and you can tell the difference between the formation of an acid, the formation of a base, and the formation of a salt by their binding components. If the H plus is the cation, you've got an acid. If the OH minus is the anion, you've got a base. And if there any other metal and non-metal combination that's forming an ionic bond, that's going to be a salt. So these are just some listings of different acids that you will see commonly. The acetic acid is hard to see because the cation is not listed in this equation first like it is in all the other acids. And so this is the actual acidic proton in this case, the one that comes off. And so you can see the ionic form is shown next to it over here. So this is the full acid. This is what the conjugate base is going to look like once that H has been donated. So you can see this one is losing one of these H's. This H is lost, this H is lost, this H is lost. when the H's are in the cation position, this is when you're going to recognize that you have an acid present. You're just going to have to memorize the acetic acid and know that the acidic hydrogen is located at the end of this molecule. This is actually a really good molecule to memorize anyway, because it's really important when we get into biological systems. It's one of the most common acids in the body, and it's the predominant one that's utilized to produce ATP or energy. So understanding and getting to know acetic acid will be a good use of your time. It's not a waste of time to memorize this one.